Dear students, I welcome you all to this informal class. Through this video, today we are going to learn some left out or missed out questions which we were unable to do in the class earlier. So as the topic mentioned there, it's nothing but just repetition or extension of zeros and coefficient of quadratic polynomial. We'll try to learn this thing in this video. Hope this will make you understand. So here we go for the questions and the concept. So at first we'll just revise the concept based on this particular topic, though we have done earlier, but I think it will be better for us if we revise it once. So as we know, any quadratic polynomial is given by p of x equal to ax square plus bx plus c. This is what we learned earlier. So let px equal to x square plus bx plus c if alpha and beta are the zeros of px, then we know the relation between zeros and coefficient. Sum of zeros, let me mark number 1, is nothing but alpha plus beta is equal to minus b by a. This is what we learned earlier. Second, product of 0, alpha into beta is equal to c upon a. Now this is the concept we need here, and beside this we need the algebraic identities. Some of the algebraic identities we will use here, or we will need here, and those identities already we have discussed, I have given to you in the class. So refer that identity wherever it is required. Okay, now let's go to the question. The first question, let me note down the question for you. Question number 1. If 1 is a 0 of the polynomial px equal to ax square minus 3 into a minus 1 x minus 1, then find the value of a. Well, so this is the question, so it's not difficult to find out. This is in fact the easiest, simplest question on this particular topic. Well, so our polynomial is, we have p of x equal to ax square minus 3a minus 1 x minus 1. So if we see this polynomial, if we compare this polynomial with the general form of quadratic polynomial, we can easily see the value of a here is a only. The value of a is a, and b, if we compare b is nothing but minus 3a minus 1. So b is nothing but b is the coefficient of x. So here the coefficient of x is minus 3a minus 1. Constant term c is minus 1. So when we compare this thing and try to use this relationship between zeros and coefficient, we find here, so we know here if 1 is the 0, since according to equation it is given 1 is the 0 of the polynomial, and we need to find the value of a. So this particular polynomial has no direct relation with this relationship. So what we can do, we'll write the given thing 1, since 1 is the 0 of px, therefore we can write p of 1. Why? Because this x will be replaced by 1, because they said 1 is the 0 of the polynomial, so this x will be replaced by 1. So we can write p of 1 is equal to 0. P of 1 is equal to 0. Now we can continue here. This is based on class 9 concept, in fact. So there you have learned that remainder theorem. So using that remainder theorem or the factor theorem, we can find out this unknown a. So wherever we have x, we'll replace all this x by this 0 1. So what we'll do, I replace this x by 1 and I made it 0. So why? Because 0 means it must be equal to 0. When we replace this x by 1, this must give you 0. That's why 0 comes here. Then so 1 equal to 1 is the 0 of px, therefore px equal to 1. So we'll replace x by 1 in this given polynomial. Okay, so it is a, x is nothing but 1, so we can write 1 square. Then we have minus 3 a minus 1 x by 1 again. Then we have minus 1 equal to 0. Now if we proceed further, we get 1 square as 1. So a, now we can multiply here 3 into a. It's 3a with minus 3 into 1. It will be 3. This minus and minus will make plus here. And this 1, since this 1 is multiplying with this one, this term, so this will make no change here. So finally minus 1 equal to 0. Now we can solve it. A minus 3a is minus 2a. 3 minus 1, no, it is plus 2. Plus 3 minus 1 is plus 2 equal to 0. So we get here minus 2a. This 2 we can shift towards right hand side, minus 2. So this minus we can cancel from both. So a becomes 2 by 2 equal to 1. So this is the value. So this is the value of a. So this was easy. Now we'll move on to the next question. We'll see Next question. Question number 2. If the zeros of polynomial x square plus bx plus q are 3 and 2, find the values of p and q and write the polynomial. Okay. So here it is told, we are given 3 and 2 are, or 3 and 2 as zeros of this polynomial, and we need to find the values of p and q. And after finding p and q, we need to write this polynomial in standard form or the actual form by replacing the values of p and q. So 3 things we need to do: first to find p and q, and then to rewrite this polynomial using the values of p and q. So the solution we'll write here: let px as x square plus bx plus q, or we can make this one as gx. Instead of writing px, we can write gx. Okay, since 3 and 2 are zeros of px, so we can write alpha as 3 and beta as 2. So we can write in any order. We can even change alpha by 2 and beta by 3, so that will make no difference. Fine. Now here we will see that relationship between zeros and coefficient. So first we'll use, because we know both the zeros and we have this thing with us, so we can easily do. First, then we know sum of 0, alpha plus beta as minus b by a. So I can replace alpha and beta values, alpha and beta, so it will be 3 plus 2 minus b by a. So if you see the polynomial, given polynomial here our a is 1 here, b is p, and c is q. So this minus will remain minus, b will be replaced by this p. So when you compare this with the standard polynomial, standard form, ax square plus bx plus c, so p is nothing but b. So I can replace this b by p upon a x square, coefficient of x square is a, and that is nothing but 1 here, 1 we have, so 1. So on cross multiplication, this will give 5 into this 1 into 5 will give you 5, so is equal to minus p. So I can write here further p, 5 is minus p, so we want the value of p, so this minus will go with 5, so we'll get minus 5. So the first value we got p. Now in the same way, similar way, we can find out q by using here I used sum of the 0, so there we can use product of the 0. So by that we can easily find out q, and once we get both the values of p and q, you just replace here, you will get the required polynomial.